Can you hear me okay? Yeah, looks like it. So what developers get for free? So my name is Louis, as Kevin said. I work for this little training business named Pentester Lab, and I teach web security code review. And when you teach security code review, you need to create the content. And to create the content, you need to do code review. And you need to analyze CVE, and you do that across several languages because that's a lot more fun. So I look at PHP, I look at some C#, even some Python, like a lot of different languages. And when you do that, and you do that across like a lot of code bases, there is something that is like pretty clear pretty quickly when you look at all these different code bases, is that how much developers can leverage their ecosystem, so what comes for free, and what's the impact of that on security. Let me give you an example. I can't see you, but anyone here like is reviewing like C#? Sorry to hear. So when you review C#, it's okay, no, not the language being bad or whatever, but I'm going to walk you through that. So, you know, I go to, like, I start doing source code review, I get like new code base, I'm very excited. Oh, they have authentication. Microsoft ASP.NET Core identity. So they don't write authentication, they get it for free. Oh, they use JWT. And if you have heard me speak before, you know that I love JWT. And same thing, system identity model token.jwt. So again, something that comes kind of for free from Microsoft. They use encryption. Oh, system, security, cryptography, again, for free from Microsoft. They use UUID. A lot of people tend to get their UUID wrong. System.guid, again, for free. And they do like, how they do password management, how do they hash them, and how do they upgrade them when they need like a new hashing algorithm, because like something is weak in the previous, and how do they automatically upgrade those? Oh, they use Microsoft ASP.NET Core identity password hasher. So basically, when you review C# application, it's pretty boring because you spend your time going back to Microsoft codebase and looking at what the codebase is actually, like what Microsoft is actually doing, and then you try to find people get it right. But like most of the code review in C# is like not as fun as other languages because developers got a lot for free. And they got all that security for free. And that's kind of what brought me to do that talk, because I wanted to share that, because like some of the things I see is really interesting, if you're a nerd. So my idea is like you have two sides of an application. The part that is developed internally, so by the developer, like in your enterprise or organization or whatever, and you got the free stuff. And the free stuff comes with the language. Language have a lot of things that are providing you with security functionality, like splitting a path, like getting a path and getting the file name from it, getting a file name and getting the extension. Doesn't seem like something that has security, that has a security impact, but totally does, because most of the checks you're going to do for security are based on how you retrieve an extension, for example, from a file name. Then you got the framework. Framework as well, like gives a lot of security for free. And finally, all the libraries, one of many, that the developers are going to leverage to create the application. And you go from something like from the least trusted, like the libraries, to the most trusted. Most of the time, you will trust the language you're using. Yeah. But you may not trust as much the libraries because you download them from GitHub, and then like you have supply chain issues, blah, blah, blah. So yeah. And also, like, what's the impact for security team? Like what is developed internally is likely a bit less mature, so you may spend more time reviewing it. And also, workload-wise, it's only reviewed internally, like no one else is going to look at that, so it's going to be a lot of work. We're going to get back to that. Where the free stuff is likely more mature. If you like get, you're using like ASP.NET like classes or code, it's likely that it's going to be a bit more mature than the guy who wrote the same code, who is writing code in your enterprise. No offense. Not meaning that the code from Microsoft is perfect, but it's pretty good. They got a good team. They got a lot of people working on it, and potentially a lot of people auditing it to a level that not everyone can afford to spend as much time on their own code. It's also open for public reviews. So potentially, everyone on the internet can review that source code. The reality is not there, trust me. Like pretty much no one reads source code. So yeah, but potentially that can happen. And finally, if you're like from an enterprise, all this code, you can review it once and reuse it in your enterprise because you review it once and you think like, okay, it looks all right, and then let's reuse it everywhere. Between these two, developed internally and the free stuff, there is like one zone that I really like is the title will make sense in a few seconds. The danger zone. So basically, between, tough crowd, come on, it was okay, it's an okay joke. So basically, thanks. So basically, if you look at people leveraging free stuff, there is one zone that tends to be where a lot of cool bugs happen. And this zone is the danger zone, and this is the where the two code base, the two components meet, and the interaction between those two components, because people tend to not get it right. And we have plenty of examples of that. We have CV 2024-3400, recently from Palo Alto, where they were using Golang Gorilla session, and they forgot to remove, to prevent directory traversal when using them. And kind of like Gorilla session is expecting developers using the library to prevent directory traversal, and the developer using the library thinks Gorilla is doing that, so they don't need to do it. And you have like, you're in this middle, like in the interaction between components, where it's a bit blurry who is doing what security-wise. And that's why the danger zone is a really good place to look for bugs. Same thing in GOGS. You had like an RC, CV 2018, 18925. Same thing in Ruby on Rails with 2016-2098. Again, like this zone where you have like interaction. If you look for bugs, really good place to look. And in the same way, like it's kind of like shell shock is like interaction between components. You tend to have friction, and the security boundaries are not clear. So look at that if you want to look at bug to find bugs. If you look at the evolution of that, 25 years ago, it was probably like that. You had pretty much nothing, and we pretty much here with like a lot more free stuff, and hopefully it's going to keep going, and like developers won't have to write any code that is that presents big security risks in the future. We're not there, but hopefully we'll get there. And another aspect of that is how much of this code should be part of the framework and the languages being used. You want to minimize the libraries that a code base is using because it's really hard to maintain and a lot riskier to keep embedding libraries in your application. If you are anyone reviewing some Node.js, now what do you think of dependencies? Like Node.js ecosystem is basically that, like people just loading library to check if a number is odd or even. So like you really don't want that because it's fun when you develop the application the first time, but over time it's a nightmare. And it gets even worse if you do that and you have a lot of application to do security for. And especially if every single application is using the same free code or not. If all your applications are leveraged .NET, it's going to be a lot easier than if like you have two applications in .NET and two applications in Django and two applications in Ruby and things like that. Because once you review the free stuff once, you're done. You just need to review how people are using the free stuff. And it's a lot less work for AppSec. And also for compliance, for ops, like if something breaks in the middle of the night and you have 20 different frameworks, it's going to be really hard to fix it up and put it back up. So having just one framework or one language that you're using across everything is a really good idea. And same for compliance. If you know that all our services, all our applications are using the same stack, it's going to be a lot easier to know like, oh, our passwords are hashed because it's always the same way. So there is less work for compliance. And in a world where there are a lot of people developing applications, and only few people doing security, we should care a lot about that. But let's look at how it all started. Back in the day, people were writing a lot of PHP. I'm talking like, yeah, probably like in the 2000s, and a lot of PHP was vulnerable to SQL injection. So the PHP team came up with this amazing protection named Magic Codes GPC. Just to be clear, that's sarcasm. So basically, the idea of Magic Code GPC is that you need a single quote or a double quote to do an SQL injection, which is wrong. And so what Magic Code GPC was doing is basically maybe now it's big enough, I think. If you have an SQL query here and you do select star from users where username equals and you have like user in between single quote, with Magic Code GPC, you see the single quote here being escaped, where without Magic Code GPC on the other side there, you can see that it's not escaped. And that was the way Magic Code GPC was preventing SQL injection. And the problem is that when you do SQL, you don't necessarily have a single quote. So if you don't need a single quote, the protection that only prevents single quotes doesn't work. So here we can see that we have select star from users where ID equals and an ID. We can see that compared to the previous one, here we don't have the quote after username equals, we just have directly the ID. So here, if you do ID equals 1, you got the good thing, like it's working properly. But if you do ID or 1 equals 1, you can have an SQL injection. And there is no single quote, so Magic Code GPC does absolutely nothing. Then came Ruby on Rails, and I'm a big Ruby guy because I got good taste to start with. And now Ruby is really good. Like Ruby on Rails, when it started, it was really good because it was basically you don't write SQL anymore. And that was solving at the time a lot of problems. Because if you don't have to write SQL, it's less likely that you're going to mess it up and create SQL injection. What was really good as well with Rails, so that's the first part of the documentation of the first commit of Rails. So not the first version, the first commit. And I think that's probably 2012, something like that. Don't quote me on that. And already in this first initial commit, they're explaining how to properly do query that won't be vulnerable to SQL injection. So pretty impressive for something that is not even in version 1.0 to already have that in mind and provide security like that. So with Ruby on Rails, you don't write SQL queries anymore. Something they did that was really cool is to prevent cross-site scripting. With version 3.0, they made HTML escaping by default. So every time you echo information in a page in Rails since version 3.0, which is like a long time ago, this information is HTML escaped, HTML encoded. So it's very less likely that you're going to have SQL injection. And if you want to echo some data without the HTML escaping, you need to use the keyword row to say like, okay, like don't encode it. So what's happening with that is you make secure the default and insecure obvious, which is a really, really good property if you're doing AppSec, because then it's really easy to know when people are doing the wrong thing and tell them that's the wrong thing. Not good. And what I really like about Rails, and at the time it was really, really novel compared to everything else, is that the security is disguised as productivity. You got all this stuff, and it's like in Scooby-Doo, you know, they remove the mask. Oh, your productivity. No, you're actually security. Kind of like that. I'm not really good at doing Scooby-Doo, I'm sorry. But yeah, basically, if you can make people more productive, and you have like security that is hidden in a corner and they get that for free, they're very happy. Where if they need to do like a lot of effort to get security, they're going to hate you. And then the dark days of application security, microservices. So it was back to zero. People like developers start to like use minimalistic frameworks with barely anything for free. They got back to writing SQL queries. Also exploring like emerging languages, emerging frameworks. That's what I used to call resume-driven development. So basically people were adding as many technologies as they could in their resume, which is great for them, but not so great for security because people don't realize how much knowledge, and especially security knowledge, is embedded in framework history. Basically, when you have software that have been used by thousands and thousands of people, thousands of people have used it, have maybe looked for security bug, or maybe the application they created was pen tested, and then they found a security bug, or whatever happened. But when a framework is 20 years old, you know that the history is probably pretty good, because at one point in time, at least one person looked at it. Where if a framework is like 2 months old or a year old, it's a lot less likely. And also you have the cycle of people forgetting about some aspect of security that come back like 10 years later, like things like HTTP proxy, like when you can inject an environment variable and things like that. People tend to forget about that, and then they get owned in the next version of their framework, and then they remember for 10 years, and then they go to another framework, and nice little loop. So the good thing with modern frameworks is that you don't write SQL queries, you get HTML escaping for free. And what is interesting as well is all around authentication, and I talked about that with .NET. Nowadays, developers shouldn't have to pick a hashing algorithm for passwords of customers. Like, they shouldn't, don't do it. So Ruby on Rails doesn't have that, but auto-upgrading the hashing used for password. Also, things like complexity enforcement. That's the thing you can have now for free in modern framework. And as much as I hate Python, let's look at Django. Django is really good. I was surprised. I was annoyed because I hate Python, but surprised because it's pretty good. And that's what they're doing. So maybe a bit small, but basically, when you check your password, so I'm logging in, I'm like, okay, I'm Louis, my password is password123, and I'm logging in. And I go against that code, bang, it check my password. And what it's going to do is first create that function. This function is used to update my password if needed. Then it's going to go to that code here, and it's going to go in the verified password here. What this verified password does is verify that my password matches the hashed password that is in the database. If, when doing that check, this function returns two things. Is correct, if the password is correct or not, and what's the name? Must update. And this must update tells Django that, if Django needs to rehash your password while you are logging in to move to a new hashing algorithm. And to do that, it uses a function that it set earlier on. So if I am logging in an application, I didn't log in this application for 2 years, and my password was using, bcrypt, and now the Django decided that pbkdf2 was a lot better, automatically, my password will be hashed with pbkdf2. And it gets better. If Django 2 years ago was using pbkdf2 already, but only with 10 iteration, and now they move to 11 iteration, that will happen as well. So if you have developed web application with authentication in the past, your mind may be blown right now. I know I was when I looked at that code. And Django also has a lot of cool stuff. So this is one of the validators. So they have by default validator to validate your password for complexity. To say your password can't be password, which is pretty obvious. But this one is one of the cool ones where they actually say, okay, I'm going to look in your user record, who you are in the database, and Louis, my password cannot contain Louis. But my password can contain Kevin, for example, because I love Kevin. And Kevin's password can be Louis, because he loves me, but it can't be Kevin. And they do that automatically, and you have that for free, again, when you're using Django. And it's very, very impressive, because that's code that, as a developer, if you use Django, you get for free. You don't have to maintain, you don't have to think of. It's just happening for free in your application. And just for compliance, for AppSec, it's a lot of security feature that you don't have to care about. Now, let's talk about improving the free stuff, because we can always improve. Trust me on that. The first thing is the principle of least astonishment. Like, you don't want to have framework language or libraries that bring surprises. Like, it's a really bad idea. Like, all of those languages, frameworks, libraries should be very, very predictable for developers, especially for a new developer. One of my favorite counterexample is os.path.join in Python, where if you join two paths, one is /tmp and the other one is /etc pathwd, it will return /etc pathwd. So if the second path, or any, like the last path start with a slash, it's going to return the absolute path. If it's an absolute path, it's going to return it. Very surprising for most developers. I got a better one. Path.clean. Anyone works at Google here? No? No. So if you are a Golang developer, a Go developer, when you talk about cleaning a path, it's actually making it as small or as short as possible without changing the meaning of a path. For everyone else, that's removing directory traversal. But if you're a Golang developer, that means we're going to keep the same meaning but remove all the duplicates that don't make duplicates when you're talking about path. So path.clean of // etc pathwd will return // etc pathwd. And you have that probably at least 100 CVs in open source project because of that. The most known one is probably Grafana a few years ago, 2 years ago. But yeah, and if instead of // it was // that will end up being etc pathwd. But yeah, back to JavaScript. Any idea of what that returns? I would be pretty impressed if someone finds it. Okay. What? Banana. Nice. So what's banana? Yeah. So you want to limit the amount of surprise in the language. And so basically why it works? Because B plus A, BA, then nothing plus Z return none, not a number. Then none plus A return nana. And then BA plus nana returns banana. So you get the idea around least amount of surprise, I guess. That's something and not necessarily a security impact here, but that's something that is very surprising and that may have a security impact. So you really, really want to avoid those. Also, another thing is around documentation. You can have the best framework, the best library, the best language, or anything. It's only as good as the documentation. If people can't find your documentation, or if it's hard to navigate to find things, they're not going to take the time to do it. They're just going to say okay, is there a function doing that in PHP? I can't find it in the documentation, so it doesn't exist. So they're going to reinvent the wheel, and when you reinvent the wheel, you get in trouble. Or if it's confusing, ambiguous, outdated, or incorrect, anything that can make the documentation not work when developers really need to access it, but that's probably before ChatGPT, but anyway. That's going to end up in insecure implementations and also security features that are left unused. If you don't know that you can do all of this password hashing and stuff for free in Django, you may be tempted to reinvent the wheel and do it yourself. And I know that in a few code bases, people do that in .NET. And that's where I'm dinner, winner, chicken dinner. That's the sentence, yeah. So yeah, another thing we are really bad as security people is trying to do something that is perfect. And perfection is the enemy of done. And most of the time we don't implement security feature because they're imperfect and someone can find a bypass. So a lot of people just say okay, we can find a bypass, so it's not worth implementing it. As a reminder, the whole WAF industry is based on there is a lot of bypass, but still worth implementing it and selling it. So a good example of that is in Golang. So Golang has this function to serve files, name serve file, that takes three parts: the response writer to write the content of the file, the request to have the request because we need the request, or you will see why, and then name. Name is the file they will serve. Then what they do is they call contains dot dot, and they could call contains dot dot on the URL path. So not on the file name, on the path provided in the HTTP request. So basically, that's what the contains dot dot does. Basically, looking for dot dot in the string that is passed. So here they do like, if there is no dot dot, they return, otherwise they split the content based on slash or backslash, and they try to find a dot dot. But what is crazy is like what I was saying, that it's not based on the file name you're trying to serve to the client, it's based on the URL. So they're not the same thing, and this is crazy, but like, yeah. So basically just like, yeah, instead of using the name, they use the name of the file they're serving and looking for a dot dot in the name of the file. They look for a dot dot in the URL. And it's crazy, 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 because it's not bulletproof. It's terrible protection, but it works. Like, it works. It just like block like 99% of directory traversal in Golang when you use serve file. Because that's like, it's exactly blocking the pattern, but 99% of developers in Golang were getting wrong, and that was good enough. And it drives me nuts as well, because it's interesting to see like how Magic Code GPC was a big failure and really didn't work, and really like, because probably it was only like solving half of the problem, where like this is simple, it's done, and it just works. Also, what can be done around getting more for free is improving languages. Languages are getting a lot better at security. And like PHP has a really bad reputation, and maybe because of Magic Code GPC, you don't know, but like it's getting better and better and better. So basically back in the day, before PHP 7.0, you could gain code execution if you had control over a regular expression in a preg replace here. We're going preg replace, so we're taking the string test, we're replacing test with this value get current user. You can't see my mouse, so it doesn't make sense, but yeah. And basically, with the E flag here, that at the time was telling PHP, do the replacement, and once you're done with the replacement, run the result as PHP code, which is mental. But yeah, like many like websites got owned because of that, and so they decided to remove the feature. PHP again, that's type juggling. So basically, if here you compare one backtick ID backtick, and you compare that, so that's the value of $A. If you compare it with the value 1, it's going to return true, because it does a cast and it's comparing the string 1 backtick ID with the value 1. The string becomes a 1 and just a comparison, and then here you get code execution. That's also something they changed with PHP 8.0. So improving languages is really, really important. Yeah, number 2, this one as well, when you do assert, you want to kill the flow of the code. To say like, okay, we put an assertion. If the assertion is false, we stop executing the code. That's what most programming languages are doing. PHP wasn't doing that until 8.0. They also changed that behavior. So before PHP 8.0, the code will keep executing, and you will see the hack here, echo hack. After PHP 8.0, what will happen is you will get an error, and here you can't see the hack on the other side, on the side here. So basically, little by little, making the language less surprising and more secure by default. Another one is around like single quote in PHP. They had this big problem. That was really good, really easy to have XSS in PHP because of that. Before PHP 8.1, they weren't escaping single quotes. So basically, if you had a single quote, if the delimiter for some JavaScript was a single quote, you could gain cross-site scripting. Now they're escaping it as well. So they're escaping everything that may be dangerous. So PHP is getting better, and people who are just upgrading to a new version of PHP to host their application get that for free again and again. And that's a big change for application written in security. So if we look at what the next stage is, I think one of the big things we can see at the moment, it's a lot of directory traversal, like things around path manipulation. But there are already a few answers. One of the ones I really like is Java. So Java has, so when people manipulate path in Java, what they do is either use strings and be like, okay, does my path starts with /var/ww, and they use a string to do that. Another option that you can use is path starts with, and that will actually understand what a path is. So yeah, maybe a bit small, but if you check foo/bar, that starts with foo and foo/bar if you're using path.starts with, but that doesn't start with f or fo because that's not the same path on the file system. And path.starts with understand that, where if you were just doing string comparison, foo/bar starts with f and fo. So that's just like basic change, but that makes a lot of sense for security. And a lot of applications don't get owned just because they make that move to path starts with. Another one that is interesting is in next version of Golang in February 2025, they have added like os.root, which is just basically all the normal file operation, but based on a given directory. So basically, by doing this new thing in Golang, you can prevent directory traversal because they're going to tell you, like, it's going to tell you, like, this is from where you can open file and you can't traverse, like, further down in the file system, and you block all of these attacks for just a little bit more work. Another thing that people tend to mess a lot is URL, hostname, domain validation, and most programming language, most frameworks, most libraries, or all of them, as far as I can tell, don't really have function to say, like, is a hostname part of a given domain? Is this URL pointing to a given hostname? And that sounds like very easy to fix, like as in like very easy to to write in code. It's actually not that trivial, and a lot can go wrong. And you have like a lot of server-side request forgery, a lot of cores like cross-origin resource sharing issues that are just based on the fact that programming languages or framework don't have function providing that to user. And the most common one is, like, for example, people will say like, okay, I only want to authorize google.com, and they will check for the suffix google.com instead of looking for the suffix .google.com, and you can use hack google.com, for example, and that will bypass a lot of filters. Right. So obviously, hopefully I've convinced you that security should pay closer attention to the free stuff, and the more, the better, like reviewing code, reviewing the free stuff, getting like all this stuff that developers can just leverage and not even having to think about security because they get it for free, they got password hashing for free, they got password complexity checks for free, they got all these things is really, really important. And especially if you can have security like hidden as part of productivity and people don't see it and they like just get it for free because a lot of developers don't care enough or don't have the luxury to care about security because they're like time poor and they have a lot of constraints. Otherwise, I brought like a lot of swag, so if someone wants t-shirt or socks, don't hesitate, hit me up after that. And thanks for your time, and hopefully you're convinced that we need to get free stuff for developers. Thank you.
Busted.